Greetings everyone. My name is Mayank Kejriwal and this is my submission for the project of ELP which I have made on the topic of transformers. This is how we'll go through the video. First we'll talk about the introduction and the working principle of the transformers, then its construction and the comparison between the ideal and practical transformers and its losses and its advantages, disadvantages. It is an electrical device that transfers electrical energy to two or more systems using the principle of electromagnetic induction. It was discovered by Otto Blathy and Carolus Zeperskoy in 1883 based on the Faraday's law of induction discovered by Faraday in 1813. Now we'll discuss about the working principle of the transformer. As we have already told that it works on the principle of current induced due to magnetic induction. This phenomena was discovered by Faraday in 1813. Here what happens is if we take a coil and wrap it around a magnetic core, then we have two voltage ratings. There's a primary voltage rating and a secondary voltage rating. We pass current through primary voltage rating, a time varying current, and due to the time changing magnetic field, we know current will be induced in the secondary voltage field. There are several types of losses also which happens in this transformer. Like you can see that since the resistance will never be zero of the inductor in real world, so some current will be lost through that. Also the flux windings also some energy is lost. So now moving on to the losses which will. Now we know there are two types of losses. There is iron or core loss, which happens due to eddy current loss or hysteresis loss. We'll observe that what each loss is and how it affects and how we can minimize those things. Okay, moving on to the next slide. The eddy current loss. First, we'll be discussing about this. Now, we know to do a time varying current field in the core, a current is induced in the core itself. See, our purpose in the transformer is to induce current in the secondary voltage in the secondary coil. But since the core is also magnetic, due to the time varying magnetic field, the current is induced there also. This is known as the eddy current, and the heat generated due to this current is known as eddy current loss. We can minimize this with the help of laminating the core to avoid the short circuit. If we laminate the core, that is use several layers of the core and insulate it with from each other, then the resistance will become low. Although then also the current will be induced, but then we'll get minimum core loss, minimum eddy loss. Now we will discuss about the hysteresis loss. Now when an alternate current is passed to the primary core of the transformer, the alternate magnetization and demagnetization of the core results in the loss of energy. We know since the core is made of a magnetic material, when a magnetic field is passed, the domains of the core will align itself in the direction of magnetic field. And when a reverse magnetic field is passed, it will happen there. So due to this alternate magnetization and demagnetization, due to the retentivity and coercivity of property of the magnetic material, some magnetivity is left in the core. And what the loss which happens, the energy loss which happens due to this retentivity and coercivity property of the core is called the hysteresis loss. Now we'll discuss about the mathematical formulations, basic mathematical formulas which can help us calculate find the properties of a transformer. Like the voltage in secondary coil by voltage upon primary coil is always equal to turns in secondary coil by turns in primary coil. This we get from conservation of energy part. And for calculating the efficiency of the transformer, we know the formula is output power by input power. And the output power we can calculate, and input power will always be equal to output power plus all the losses. And since from the second law of thermodynamics, we also know that the efficiency can never be greater than 1. So when we substitute the proper values, we get the final value of efficiency as output power plus divided by output power plus iron losses plus copper losses. Now discussing about the applications of the transformer. It is one of the most widely used devices nowadays. Like the current we receive in our home, in our houses or in our colleges is with the help of a transformer. It's used to transfer electricity to a great distance where we need to minimize the value of current so that the current loss, the heat loss is minimized, that is I square R. So we use a transformer there to minimize the current and transfer the current through large distance. It is also used for impedance matching and isolation to electrical circuits and in coupling devices among others. I would like to thank the following websites for help: the Microcontrollers Lab, the Wikipedia.com, and ELP.ocs.com. And also would like to thank our course instructors, Mr. Anuj Dhawan sir, for helping me making this practical experiment. Thank you.